Hello everyone, how are you? I hope you're having a good day. This video is about the zeroth rule of algebra, which is letters are numbers. If you've just started learning algebra, it can be quite confusing to think about letters as numbers, but it is an incredibly important thing to do. This video assumes you have studied a little algebra already, and maybe you're finding it difficult. It is not meant to be a first introduction to algebra. Let me know in the comments if you want to see that video. It also assumes you have studied some fractions, including adding and multiplying fractions with different denominators. Also, remember that in algebra, when we write AB, that equals A multiplied by B. And when we write A over B, that equals A divided by B. Let me start by running through some basic examples of using letters as numbers. We will see these examples again at the end of the video when they will hopefully make a bit more sense. You already know that in algebra we use letters to stand in for numbers we don't know, but the numbers are always the same if we use the same letter. And so we can say that u minus u is going to be 0. We don't know what the value of u is, but if you have a number and you take that number away from itself, you will end up with 0. In the same way, u plus u is going to be 2u. If you take that number and you add it to itself, you're going to have 2 times that number. Moving to multiplication, u times u is going to be u squared. And this is u raised to the power of 2. Any number times itself becomes a square number. And finally, u divided by u is equal to 1, because any number divided by itself is going to be 1. It does take some practice to get used to using these in algebra equations, and there is more to learn than just these 4 simple cases, but these are basic examples of how we use letters in the same way as numbers. Let's go on to a practical example now. Here is a simple question that you might see on an algebra paper. Show that these two formulae give the same result and explain why. On the left, f equals u plus v over uv, and on the right, f equals 1 over v plus 1 over u. The formulae do look quite different except for the fact they both use u and v. First, let's check that these formulae do give the same result. First, let u equals 10 and v equals 5. If we substitute those values into the equations, we get this. Looking at the left-hand equation first, 10 plus 5 is 15, and 10 times 5 is 50. So in this equation, f equals 15 over 50. But this fraction can be simplified by 5, and then we get 3 over 10, because 15 divided by 5 is 3, and 50 divided by 5 is 10. If we now look at the right-hand equation, then we can see that we are adding fractions, and when we add fractions we need the lowest common denominator, which is 10. 1 over 10 already uses this, and 1 over 5 needs to be multiplied by 2, so we end up with 2 over 10 plus 1 over 10, which, as I'm sure you can see, is also equal to 3 over 10. So the two formulae give the same result. Let's just try another example with some slightly bigger numbers. Let u equals 15 and v equals 70. Substitute those numbers in, and again let's look at the left-hand equation first. 15 plus 70 is 85, and 15 times 70 is 1050. Once again, we can simplify by a factor of 5 to get 17 over 210. On the right-hand side, 1 over 15 and 1 over 70 have a lowest common denominator of 210. So when we multiply up, we get 14 over 210 plus 3 over 210. And once again, the answer is the same, 17 over 210. Both of these examples were easily divisible by 5 just to keep things simple, but the same thing will happen with any u and any v that you choose. I suggest you try a few more pairs of u and v and make sure that this happens for yourself. So we can see that the two formulae give the same result, but why do they give the same result? I will go through this question in 3 ways. But remember that I am really just doing the same thing 3 times. As we go from the first to the third example, notice how we can use letters in the same way as we use numbers. Method 1 is to rewrite the problem using normal division. Again, let's let u equal 10 and v equal 5. And remember where we started on the problem, with these two equations. On the left-hand side, we can divide this into 2 fractions. That is 10 over 10 times 5 plus 5 over 10 times 5. 10 over 50 plus 5 over 50 equals 15 over 50. But what we are going to do is multiply the numerators by 1. This doesn't change the value at all. Multiplying by 1 doesn't change a number. But now we will break this into normal division and multiplication symbols. The left-hand bracket becomes 1 times 10 divided by 10 divided by 5. And the right-hand bracket becomes 1 times 5 divided by 10 divided by 5. In each of these brackets, you can see that times 10 divided by 10 cancels out to 1. And times 5 divided by 5 also cancels out to 1. So we are left with 1 divided by 5 plus 1 divided by 10, which is exactly what we have on the right-hand equation, 1 over 5 plus 1 over 10. Method 2 is to use the rule of multiplying fractions, and if you have forgotten that, then a over b times c over d is equal to a times c over b times d. We'll use the same values for u and v, and we'll start in exactly the same way. First, we break it into 2 fractions. Then we multiply the numerators by 1. We can see that each of these brackets is like a multiplied fraction, and because multiplication can go either way round, we can choose to arrange the numerators and denominators how we like. So we get 1 over 5 times 10 over 10 plus 1 over 10 times 5 over 5. But 10 over 10 equals 1, and 5 over 5 equals 1. So what we really have is 1 times 1 over 5 plus 1 times 1 over 10, which again is exactly the same as our right-hand equation, so the two equations are equal. Method 3 is to use letters like numbers in the algebraic ways that you have studied. We're going to use u and v this time instead of 5 and 10, but we are still doing the same thing. On the left-hand side, we break it into 2 fractions, and we have u over uv plus v over uv. We can also multiply the numerators by 1 again, although we don't have to do that. We can assume that the 1 is there. However, this time we're going to write it more like an algebra equation without the multiplication symbols. But we can break it up into 2 fractions, and in the left-hand bracket, u over u equals 1, and in the right-hand bracket, v over v equals 1. So what we really have is 1 times 1 over v plus 1 times 1 over u. And again, we are back to what we have on the right-hand side. The two equations are equal. So we can see that the first equation can always be rearranged into the second equation. We did not do any new maths to do this, except multiplying by 1, which is trivial. All we did was rewrite what was there already. Rearranging equations like this lets us see new possibilities, but it does take some practice. Most importantly, when you have algebra variables in your equation, you remember you can treat them like numbers even when you don't know what their value is. Let's just finish off by looking at those basic examples again. If you have an algebra equation with the variable u, then u minus u will always equal 0, because whatever value u has, if you subtract it from itself, you get 0. U plus u will equal 2u, because whatever value u has, if you add it to itself, you will have 2 times u. U times u will always be u squared, because any number times itself gives you a square number. And u divided by u will always equal 1, because any number divided by itself equals 1. I hope this video helps you to understand how letters are used as numbers in algebra. If you are still confused, try watching through the video again and leave a comment on where you are stuck. Thank you for watching.